Masq is a framework where users can build and train machine learning pipelines by using the usual libraries and put them into production directly on relational databases. Masq can then help to reduce the technical debt that usually the machine learning applications suffer when put into production. The framework is composed of three main components: the compiler, the executor, and the manager. The compiler is in charge of translating pipelines into SQL queries. The executor enables the connection and execution of pipelines on relational databases. The manager is a graphical user interface that represents an alternative to the command line for using the compiler and the executor. Moreover, it supports the capability of estimating the execution time of a pipeline on a database and implements a history of the experimented pipelines to compare the performance obtained. Let us show now how the manager allows users to implement a machine learning pipeline. First of all, we have to build the training pipeline. The training dataset has to be selected. It can be a file or a table in a dataset. Then the user has to show which is the feature where to make the inference. It can be a column of the selected dataset or an external source. The dimension of the validation set and the measure to be used for evaluating the results of the training is then selected. Then the next panel is to define the pipeline. The user selects through a drop-down menu the transformers to be applied in the pipeline. He selects the target features and the model. In this example, they are a standard scaler applied to the temperature and wind speed columns as a featurizers, and the gradient boost regressor as a model. The library is extensible. We now provide some implementation of scikit visualizers and models, but new algorithms can be easily implemented as we show later on. The pipeline is then trained and can be locally saved for future purposes. Some quality measures are shown in this pop-up menu. The pipeline can be also directly deployed. As we did before, we have to select the dataset, for example, a table in a database. Then we can execute the inference. We can first perform a simulation to see the time required for finishing the task. The number and the size of each batch where the dataset is divided has to be inserted. The pop-up menu shows the time required both running the inference on the database and in memory using the original implementation. If the simulation button is unflagged, the query is executed either in the database or in memory. A CSV file with the prediction and the query executed is shown. The History menu allows the users to view and compare the performance of already experimented pipelines. There are pipelines created over MySQL and SQL Server database management systems, and a pipeline created over a CSV file. We can see the details of a pipeline and compare the performance obtained in previous experiments. Finally, we would like to show that the Masq Manager has been designed as a flexible and extensible tool. It has been conceived according to a microkernel architecture where visualizer and learners are plugin components that can be easily added to the framework. A plugin is composed of two parts. One is the original visualizer or learner taken from a machine learning library. The software interfaces of this component have to be adapted to the ones used by the manager. The second is the implementation of the component in SQL that has to be designed by an expert.